Welcome to the GOTO Podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello, my name is Christian. I'm a technical agile coach and author of the refactoring book, 5 Lines of Code. I'm sitting here with Michael Feathers, the author of the book Working Effectively with Legacy Code, which has helped thousands of developers since it was published in 2004. Michael, what are you up to these days?
What am I up to these days? Lots of things. I'm a chief architect of Globant, but I also do training and consulting independently as well. I think I've kind of like broadened my focus beyond legacy code in the past 5-6 years or so. But it's just been very fun. So I like to think about things at a deep level, and there's a lot of interesting things on the horizon now to play with. So it's pretty much what I'm up to.
Cool. You say you're not looking at legacy code anymore. Is that because you fixed all of the legacy code in your vicinity?
No. I mean, people keep writing it all the time, right? So it's like that's impossible. But no, it's not that I'm not dealing with it. It's just basically I think my scope is expanded. I'm just looking at some other things also. So I guess that's the best way to put it.
Okay. Well, that leads naturally to my first sort of question. If you were to write the book like today, is there anything about it you'd change?
Well, it's an interesting thing because I almost feel like the core of the book, the core ideas are kind of like a little bit timeless in a way. And that's why I guess it still continues to sell very well now. But I think it would make more nods to current technology, sort of like that it kind of like reaches the reader and says, hey, by the way, I know about this thing that you're dealing with right now, but still it's this kind of a problem of refactoring and testing, that kind of thing. So it's really more like, how do you actually sort of approach the reader, that kind of thing. There's a lot more now that I would actually say about how legacy code happens, because that's been almost like the sideline pursuit I've had over the past 10, 15 years. It's kind of like you go around and you're helping people with all these problems and you're kind of like, okay, well, how do we avoid all these things, right? And Agile has had some answers. There have been a number of other things, but understanding the real mechanics of how it happens and really how you can basically, avoid them at an organizational and individual level. It's been like a lot of what I've been thinking about, and I think I would go and add to the book, That and functional programming, because there wasn't very much at that point.
Yeah. So. Well, it seems that seems really interesting because to me, it would feel like legacy code is inevitable. It's just when code ages, it becomes legacy. I think also we should probably deal with a question that is very popular at this time, very much in the media, and it's AI and machine learning and what effect that will have on code quality and legacy code in particular. Is refactoring going to be outdated?
Yeah, well, it's an interesting thing about that. So I've been playing around with it a lot recently, and I don't know. My sense is that we're safe for a little while in a way. I think there's a couple of different things that kind of go together with this. One is that we've had code generators for ages within software development, and there have always been people who basically say, at some point we'll just be able to generate the applications and we'll be set, right? But there are always like these interesting things like, it's like, what does the thing do well? How much effort is it to go and actually sort of hone in on the thing that you really need? And I guess the other big thing with this too is that basically code is still the representational language, right? We are generating code. We need to understand code well enough to be able to go and work with it and sort of like gauge the correctness of solutions, because it's still there's like the hit and miss thing with AI right now. It'll basically give you something that's good sometimes, and other times doesn't compile, or basically it's kind of like off track because it's dealing with the ambiguity of your natural language, right? So I think we've got space, in this. But I think, in a way, prompting is just going to become another form of programming in a way, right? And then we have to kind of figure out, what do we do to go and sort of like make the stable pieces we can generate, and then the ones that require more attention. So we'll still need modularity at a very coarse-grained level in some way. Those are some thoughts about that, I guess, right?
Yeah. Sort of like it'll be a new type of REPL like ChatGPT.
Yeah.
Yeah. Okay.
Yeah.
Well,
You have to coax it and prompt it, right?
Yeah. And you have to guide it. Like you have to learn to guide it and say, oh, and I know it's going to trip up over these things, and like.
Right. So it becomes it becomes a programming language, which is a little bit more frustrating in some sense, but can do more for you, I'm thinking.
Yeah.
Which is kind of hard
because
to imagine,
programming
right?
isn't frustrating at all. I personally haven't worked much with Copilot or something like that, but it seems like people were also very into that when it came out. It was like, oh, now we won't have to do these simple things anymore. We can just ask Copilot to write them for us. Mm-hmm. And I mean, especially if you're working working a lot with tests that are fairly simple, or at least follow a similar structure to how they usually would, then Copilot might be more helpful. I don't know. Have you tried Copilot?
A little bit, not as much as some of the more recent things, but I think so. I think the thing is that everything with AI now seems to, well, not everything, but a lot of it right now just turns into this thing of kind of like generate and test in a way. And it's kind of like, so you are given things and then you have to basically, it's really on your back to go and basically figure out whether it really is the right thing or not. Right. So there's this degree, there's like this sweet spot, I think, between, I can generate a lot of things. It's kind of like, at what scale do I generate things to go and really see that they really are on target for what I need to do? I used it to generate test cases. I've just been kind of happy with what's produced in many cases. I think if nothing else, you get like, enhanced ideation. There are certain things that you might not think of, and you sort of like you become better yourself in using it because it sort of like introduces you to more possibilities, and that's nice.
Yeah, that's pretty interesting. Yeah, I've also seen people using, I think it's called procedural testing or something, more and more, where they generate a lot of sample input or whatever, and then they verify against that, I think.
Yeah, kind of like fuzzing in a sense.
Yeah, or something like that. Yeah.
Mm-hmm. Yeah, no, it's great for that sort of thing. So, cool things. Guess we'll see where it goes, right? And it's kind of funny. I'm supposing that years from now, you or I can take a look back at this and sort of say, those guys, they really quite know,
Yeah.
But, it's hard to predict the future.
Yeah, when Copilot took over the world tomorrow or
exactly right.
Yeah.
So what's the date stamp here? What's today's date? Today's the 20th or 21st?
20th of March. Date
stamp for our opinions here.
Talking about testing, your book talks a lot about testing, and it follows sort of this Agile Alliance sort of very massive on TDD, stuff like that, sort of things. So if before we jump straight into testing, how do you characterize a legacy code base? How do you recognize if you're sitting with a legacy code base?
Well, I don't think there's any hard line with it, really. I think it's, legacy is a subjective judgment that we make quite often based upon the difficulty and the hardness to understand something that we're working with. Traditional definition is it's code you got from somebody else, right? And at one point I started throwing around the idea, it's like, well, maybe it's a code without tests, because the way that you work in code without tests is qualitatively different from when you have the tests to kind of like serve as like a safety net for what you're doing, right? How you know, I mean, it's kind of like, it's really a subjective judgment. I think the main thing I keep coming back to more and more is that to what degree do you actually understand what you're working on, right? And if you have trouble understanding it and understanding what its behavior is, then you're really in trouble, right? So everything is about getting that understanding either through writing tests or reading, all those different things. And there's really a slippery slope on that. Things can kind of fall apart.
That's really an interesting take, because I would normally say that it's the level of confidence that you feel, and it's very close to what you're describing. The difference, I think, from my perspective, would be that I try really hard not to have people read code, because humans read code very slowly, and so the more of that I can skip, the better. And good method naming, for instance, and like having a good hierarchy of your code is a way to sort of eliminate a lot of the branches, hopefully eliminating a lot of the code.
Right.
And then, I mean, confidence comes from something else actually than understanding it. Like, do I trust that this works, even if I haven't looked at it?
Yeah, fair enough. And I think in the book, I kind of like nodded to that a bit, because I was talking about this thing of like, to what degree you can be surprised by what you find or what the system does, right? And I think this is a general thing. It's kind of like, when we make systems, it's kind of like there's the general thing that it does, and it's like it should be pretty much unsurprising, right? So it's kind of like if you basically find something completely counterintuitive in the code, either behaviorally through a test or just, through reading things, it's kind of like you might be thinking, well, what else is here, right? It's like, are things really to the point where they're so irregular that I feel like I'm lost or that I could be kind of tripped up by anything that happens? So fair. I think there's it is a quality of the code base rather than our understanding. So yeah, I agree.
Yeah. Well, and it's and a test is obviously one way to sort of gain some of that confidence. You also mentioned in the book, which I absolutely love because I also spend a whole chapter on that in my own book, is like leaning on the compiler, as you call it. Like the compiler is so powerful. Type systems have gotten so good. You can actually gain a lot of confidence if you know how to work with it correctly.
Yeah, definitely. And I think it's funny with that too, because I guess when I've described leaning on the compiler, the other thing that I talk about a bit is deliberately introducing errors in order to find out more about your code, right? Which I basically see as another form of testing. It's just never really quite seen that way, but it's like it's another lever for gaining understanding about what's going on in the system behaviorally.
Yeah,
so yeah,
definitely,
it's good stuff.
And yours is the first formulation of TDD I've seen that actually includes make it compile, because it seems to trip up a lot of people that red could also mean a compile error. In the red-green refactor. No,
definitely. And it's funny with that too, because I think, I don't know, it's kind of like, I think the very initial steps in TDD kind of happened in dynamically typed languages, but, definitely, Kent and people around him were working in Java, at least at the time that he wrote the first book on this. But yeah, no, it's a piece of it, particularly for compiled languages. What's kind of funny for me is quite often working with people in dynamically typed languages. It's kind of like, I actually prefer dynamically typed languages in many circumstances, but it's also like there's this thing of like you have way more affordances with compiled languages, different ways of interrogating the code base. So it's a trade-off,
Yeah. I mean, I'm a little bit unsurprised that you work well in dynamic languages because it seems like you have a lot of discipline in writing testing and stuff like that. Whereas I find my huge challenge when I'm working with dynamic languages is I don't have a lot of testing discipline. I have a lot of typing discipline. And so I'm very challenged on the confidence level when I'm working in dynamic languages.
Yeah. Well, can I tell you a little story about this? Because it's a little story I like to repeat. I think I put it in a blog a long time ago. But back when I went to college, we had a computer lab, and you'd sit in there and you'd have your terminal and you'd work on things. And we were basically programming in Pascal, right? Very early language that way. And I was sitting there and doing my assignment, and everything was going fine, but I looked at the person next to me, and on her terminal, I saw an array subscript out of bounds exception or something kind of like that. And I thought, oh my God, I've never seen that before, right? And I'd basically like gone through almost all of this introductory course and stuff like that. And then I thought about why I hadn't seen that before. And the thing is, because I taught myself programming in C from the beginning. And then I went to college and started learning Pascal, which had a stronger type system. And I just realized that essentially in C, it's kind of like if you mess up, you're in real serious trouble because there's like, it's hard to know when you messed up and then basically just get these random crazy errors because you're trouncing over memory and stuff like that. So I think there's this interesting thing about kind of starting out with unforgiving tools to go and sort of build your discipline in a way, right? It's a terrible thing to advocate because it's almost like the thing of going in and saying, go out there and march in the woods barefoot for 12 hours and you'll be a better person, right? But I think there is a piece to that as well, that basically the things which cause us to go and sort of like develop discipline sometimes are very useful for us, at least very early in our careers. So just a thought.
I totally agree. So from my perspective, I started coding in just straight Notepad, no Notepad++, no fancy thing. So I put my parens, the close one when I put the open one manually every time. I've never had a mismatched parenthesis, right? Because that wouldn't have worked back then. I couldn't have sat there counting them.
No, it's fair, but it's a thing. I think those are things that basically you need to go and sort of like, I think, develop the discipline some point in your career, then you can rely on the other things. And it's like, once you get that mindset of complete attention and discipline, it's cool because you're kind of able to go and dip into it again and dip into it on a case by case basis when you need it. So it's just another, tool that you can have. I think that's just my sense of it.
Yeah. So just a side note, actually, a side question, like, I've noticed the same thing with the debuggers. I don't use them because from back when I started coding, I didn't have one. And so I do printf debugging always. That's the only thing I do, and it always works pretty much.
Yeah.
Like, how do you have that same experience? Like, do you use the
Yeah, I just never I did use debuggers prior to hearing about TDD and learning it. Then I basically got out of the habit of it. Occasionally I'll fall into printf, but for the most part, it really is this thing of going and doing it with, with like tests for the most part. The thing I always ask myself is kind of like a design thing, is kind of like, how easy is it for me to go and figure out the thing I want to understand? And if it isn't very easy, I'm kind of like, okay, well, there's something kind of messed up about the design. I need to do something to go and at least get things at the grain where basically I have a good testing affordance to go and actually get the answers I need. So things like that. Yeah.
But then I would expect that the code base is at least as complex as the domain you're modeling. That's my general sort of rule of thumb. So then some things will be hard questions, right?
Yeah, I think they will be hard questions. The thing that's kind of, it comes down to this thing of like, well, I think, it's not like we have layers, like traditional layers in software development as much anymore, or that we really advocate having them. But I almost like, it seems to me that there are different like query layers within an application, right? So if you have a good domain model in a sense, then you basically are able to think in terms of the domain and ask questions in terms of the domain. And you might be dealing with an area of like 4 or 5 classes, for instance, but you know that you can ask the question at the appropriate level for what you need. And maybe you need to go and jump out to like an end-to-end thing to go and ask something which encompasses more of the domain and more of what's going on. But you get this ability to query at different levels, and the design of the system should support that, right? I mean, at its base level, if we have something which is basically like doing accounting, we're going to have like fundamental computations. They'll probably be held in like maybe 2 or 3 methods that we should be able to understand well enough to go and query those in the test, even if we're not asking the big questions about how all the accounts interact and stuff like that, right? So it's this thing of like developing almost like language at all these different levels. And it's not like they're specific layers. It's just kind of like the language is present all through the system. I think that's the thing I would kind of say,
Yeah. Oh, I think I get that. But it feels like some things are just inherently very difficult to sort of lower out of the system. Some information is sort of embedded deep within it, and it's like dependent on all these sort of other things. And at some point, the complexity is there, and you have to deal with it. It's like,
yeah, definitely. And I think, but it's also, and I just keep going back to that thing of like, that's a lesson for us, is when the complexity is there and it's not easily approachable through an API of some sort. Then I'm kind of like, okay, what's wrong here, right? Even if I can't fix it right away, I just basically sort of always take that as a cue for design. One of my favorite talks I ever gave was like in 2007 or 2009, I guess it was. It was called The Deep Synergy of Testability and Good Design. And I think about writing more about this and this sort of thing, but it comes down to that thing that almost everything we can imagine that's painful about testing is an indication of some kind of a design problem. If you basically address the design problem, then, you get better design, but also better testing affordances. And to me, that's kind of like, it's a beautiful thing because it basically helps us get better at what we do. And so it's kind of like you're able to listen to the system and basically learn more about things through your experience of it,
Yeah. And I would actually have the exact same view of it, just with testing instead of, with typing instead of testing. If I can't type this correctly, if I need reflection, if I need cast, stuff like that, I haven't designed it correctly.
Totally. I do like to kind of sidestep the whole thing of like, is dynamic better or static better? I like them both for different reasons. And I think that basically it just comes down to context, what you're working in and what you need, And that whole area is just kind of like, it's cool, but I'm kind of like, I'm not going to come down on one side or another on that. It's just like, it's what you need.
Yeah. I mean, you'll also have an easier time on the internet if you don't sort of piss off either camp, so to speak.
Yeah, fair enough. Well, it can be fun to piss off both sides.
Yeah. Sure.
It depends upon how you get your fun. It's not recommended.
Yeah. I've been to a lot of organizations, and I see, now that we're talking about testing, I see a lot of them are struggling with testing. Like it isn't as prevalent in the industry as I would sort of want it to be. So if a person is in one of those organizations, like how do they get started? How do we move out of this rut, or what do we call it?
Well, I kind of like the silent approach a little bit with this too, but I think it's just because, having a background as a consultant, it's like, if you go in and you basically say to people, it's like, hey, you got to do things this way. It's like, they're going to rebel, or they're going to be kind of like, who is this person who's basically telling me these things? And, sure, I feel like what I was doing was good before. So, prove it to me, that kind of thing. Right. But I think, an interesting thing is, like, an employee of an organization, you just have to do your work, and you have to do it very well. And the thing is, if you basically discover that these things help you, and chances are they will, because that's what they do, these techniques, then, it isn't very long before people start to recognize, wow, this person's having less trouble doing things. What's going on? And the people that are really interested in getting better will gravitate and learn, right? And, it's very much like, sometimes leading is not a very overt act. It's just by going and sort of doing something different and getting people curious enough to go and try things out. The thing that I find problematic quite often is that people that are like, I find a better way of doing things in an organization, they try to go and lead and say, we have to do it this way, we have to do it this way. They just create enemies, right? And, it's kind of like you have to kind of like keep your passion intact a little bit, and just sort of like, if you enjoy what you're doing and you're making things better, quite often it's going to have some kind of a galvanizing effect inside the organization, right? For a consultant, things are a little bit different, because quite often you're on the hook to go and actually change things. And then you have to go and basically sort of like sway people to some degree. And I think a little thing that I used to do with this is basically try to find the people who are, really curious about things, and also the people that other people would listen to, right? And convince them, right? Then it becomes kind of viral in a sense. And, it's great when you find a person who's in both of those camps, then, it kind of helps to some degree. But I think the other thing to recognize too is you're not going to get 100% in many organizations, right? That's just the way things are. People are different. They have different views about how they're going to go and handle things. And that's just life,
So I'm assuming you have, as a chief architect, you have teams working sort of under you, or?
No, I think chief architect is kind of like a bit of a moniker in a way. I think I kind of chose that title within the organization, Main Globant, just because I want to highlight to my friends outside of the industry, or outside the organization, that that architecture is important. I think after many, many years of Agile, there's been the thing of like architecture just kind of emerges. And I think that the kind of thinking that we do about the macro level of systems is extremely important, and that kind of thing. So I do work with different teams across the organization and things like this, various different client accounts and stuff like that. But it's not really as a direct architect role that way, right? I think it was more of a signaling thing on my part, in a way.
Yeah, no, I understand. How are your teams, or the teams you work with, how do they work? Like, do they use TDD and stuff like that?
Yeah, some do, some don't. The thing is, it really comes down to the type of engagement that's people are being called in for. It's funny because there are many different scenarios, for going and like intervening in an organization and producing value. So yeah, quite often it's definitely on the palette of things that we do. Yeah.
Right. Well, it's super interesting what you're saying before, that if you're in an organization as a developer and you start using some tool that it really helps you, right, and you're going to keep using it and somebody else is going to see it. I've actually met people in the industry who had the opposite experience with testing, where I would come in because they were on their way away from testing, and I was like, "What? Why are you doing that?" But it's because tests can sometimes hinder sort of this refactoring thing, particularly if they're very structural dependent.
Yeah. I think the interesting thing to me is sometimes I think I feel much more comfortable than many people putting some of the tests kind of like in the parking lot for a minute and saying, okay, I'm going to go and change the system, and I'm going to basically go ahead and do like a structural refactoring that I know the tests aren't going to basically cover completely. But then sort of like if I can develop confidence in another way to do that refactoring, then I'll basically run the tests and find out, well, they aren't really working against the methods they need to work against. And I'll basically rewrite tests that will cover the new structure that I have, right? I think that we can basically sort of like overly valorize the tests sometimes and think, oh my God, we can't get rid of any tests at all. And then you're in a situation where you're just so scared that you can't change anything, right? And I guess the other thing you're probably getting at is kind of like the level of testing and, how do you actually develop in a way where you aren't sort of like preventing yourself from refactoring, right? That's definitely an interesting, question, for these things.
Yeah. And I've found that a lot of the struggles that I meet with, particularly testing, would be people aren't really experienced with it when they come out of school. And then they don't have time to learn it. And it's actually not an easy skill, especially because when you talk about testing, most people focus on the red-green refactor or like sort of the processes around it. Whereas I find that the most painful thing is actually learning about how to stub things correctly. Because if you learn how to do test stubs, then everything just becomes so much easier.
Yeah, and I think there's that. I think the other thing that's wild for me to go and kind of notice is that I think that in the way that TDD kind of spread across the industry, it's like some people just basically took it to be like, okay, you write one unit test harness for each class of your system and you're good, right? But then like BDD came along and it's kind of like then you're basically covering a bigger area. And particularly when you look at what Kent has done with this and other people, I like Ian Cooper's take on this as well. It's kind of like you kind of start out growing tests from a particular point and then you're refactoring outward. You're basically decomposing things as they get bigger. So your tests are over here, but they basically cover a larger space. I think that's the key message that kind of needs to get across to people rather than this, one-to-one mapping of test classes to production classes. I think that's a way where people kind of get themselves, they kind of paint themselves into a corner to some degree.
Yeah, and especially when you start testing like private methods and stuff like that. Like if you don't stay to the public interface, then like you're just in for a headache when you want to restructure that code.
And what's wild about this too is that essentially it's like, I think, Martin Fowler talked about this years ago. It's like we don't have a good thing now to go and actually mark things as published rather than public, right? So public is a code level thing at the class level. A method can be public or not. But it's kind of like you need something which is kind of like this is an interface that we see from the outside world, but not necessarily within this particular area and unit. Of course, it goes and kind of like differs across programming languages, but that kind of separation is something that's not really kind of like built into languages. So it's not overt, and we have to go and make our sense of like these right here are the public methods that we are holding invariance on, as opposed to these other ones, right? So tough.
Yeah, and I remember having the trouble also when I wanted to write testing code that tested like not quite public to the like API, but public methods. And then the testing classes would have to be in the same package because otherwise they weren't visible. But I didn't want to compile them in the same unit, right? Because I didn't want to ship my test code. So it was just a whole trying to design around that. Well, it took like days to figure out the beautiful.
I tend to try to convince people to go and actually ship their test code. In with that, just because, well, particularly, I guess for me, I get called in to look at these really horrible situations. And it's kind of like, there's just you don't have many other options in terms of actually sort of like easing the entry into going and starting to get control of the code base, short of actually going and shipping them, in parallel that way. So, I mean, and there are some valid reasons not to do that. But I think it's still something where it's, if you can have that discussion and move to doing that, sometimes that kind of eases the transition into going and building an easier way of working with a legacy code base.
Yeah, I mean, it certainly changes sort of the whole view on. I want to ship the thing that I've tested, but I don't want the tests in the thing that I'm going to ship. So it's sort of like that constant struggle.
Yeah, and sometimes that's kind of like a sense of it's like an aesthetic thing. It's kind of like, oh well, these things are different. They shouldn't be in the same place, right? I don't know if I mentioned this in the book, but I do mention it in training quite often. It's kind of like, I think it was Voltaire who basically had this saying that when you translate French to English, is best is the enemy of good in a way, right? Mm-hmm. So you're sitting there and you're working with somebody and it's kind of like they're saying, wow, you're breaking dependencies using this technique and it makes the code look ugly. And you have to kind of like, have you looked at the code, right? I mean, it is kind of ugly, right? that kind of thing. It's kind of like some of the things that you do to go and actually start to break dependencies and get tests in place are going to violate some things some preconceptions you might have about good design, but they are there to facilitate basically doing the refactoring to make the design better. So it's cracking the eggs to make the omelet a little bit,
I mean, when you say that, we have to talk about encapsulation, obviously.
Yeah.
Which you also mentioned in the book that you don't mind breaking encapsulation if it makes testing easier.
Well, the thing is that, when you say it that way, and I'm not sure exactly how I said it, but that simplification is good. But it's not saying, hey, I'm a fan of breaking encapsulation, but selectively in particular places to go and give you the affordance to go and test things, right? And, you do it reluctantly, but you're doing it in such a way that, when you're encapsulating, you should be thinking about what it is you want to encapsulate, right? So to go and break encapsulation at the edge of a new sphere that you want to go and basically hold as your place of encapsulation is okay, because you're creating like a new boundary around something of value. So it's a matter of finding the things of value that are there and saying, where do I want to basically sort of like be outside of that to test? And you might have to break at those edges in order to go and start to form this thing, form this layer around the value that you're trying to go and sort of preserve through tests. So it's that kind of thing. I tend to think rather visually. So of course I'm using my hands doing this kind of thing. But when you think about it, in a lot of systems, it's like they're broken down in these pieces in particular ways, in particular shapes. And it's like sometimes you're looking at them and you're like, well, these three things can be part of a bigger thing. So it's up to me to go and build that bigger thing around those things, right? And other times you have a thing which has several responsibilities, and when you break it apart, and then you have a different task, which is going to be, how do I actually go and support this from the outside with tests to be able to break it apart, right?
If I'm working with something that's like legacy code, I would sort of attempt to limit the tendency of local changes to have global effects, right? That's sort of what I'm scared of. Totally. That's really the issue with legacy code, is that effects propagate in a non-local way, and humans can't seem to get that into their heads. We're used to local. So I would often try to encapsulate things harder, because that helps to sort of limit all of these effects, right? They can't escape if you encapsulate in a very hardcore way, so to speak. Mm-hmm. And I noticed that you mentioned also the three ways that effects can propagate, and it's like exposing data, obviously, constructors, and passing arguments, or mutating it directly.
Yeah.
So then I would my approach would be or my intuition would be to sort of limit the effect of the things. But then you're saying that you would have the test to sort of alert you, at least, if something changes non-locally, right? That's what the test should be there to do.
Well, I think I always look at the test as basically a way of understanding the thing, right? And it's kind of like, if the thing changes in a way that you didn't really anticipate, then basically the test is going to go and break. So I think for me, it's really the work leading up to writing the test is about going and building the isolation so that the effects don't propagate necessarily, right? Or at least you have a barrier to go and basically make sure that they don't propagate, right? So if you basically are accessing a singleton inside of a class, it's like, I want to basically sort of like find a way to go and actually inject that value through the constructor rather than basically go and, mutate the singleton directly within the class, right? And so you slowly go and start to build these firewalls against effects propagating when you're doing this. But a lot of these tend to be bigger issues in the architecture, so it's kind of like it takes a while to go and actually start to root those things out. And you have to go and sort of assess the value of doing that when you actually have the test there to go and tell you about whether these side effects actually occur in a bad way. I think it's a very problematic thing, because I think one of the things that in legacy code that's tough is that basically code grows in a particular way. And it's like, if you have like lots of global access all across the system, you're not going to be able to fix that in your lifetime necessarily, right? But you should be able to go and at least build in the sensing through tests to go and understand, where the tripwires are. If something goes wrong, you want to know about it immediately, right? So the code is less understandable by reading it, but then the tests are able to go and give you the feedback that you can't get by reading it, because things have gotten gummed up in a particularly bad way. So there is this question with legacy code bases about how far is reasonable to go in terms of your plans for how good it's going to go and get.
Yeah, please. What is it? What is reasonable? Like how much time should you invest in fixing legacy code or avoiding it?
Well, here's the thing that I think is really a very, very critical thing. You know about like the 80-20 rule, right? Like, it's like 80% of, the work happens in the last 20% of the project and all these different things. It's part of something called the Pareto principle, right? And there are a lot of natural systems that are this way, where essentially, like 20% of the code has higher value than the other 80%, for instance, stuff like that. If you do a distribution of method sizes in a project, you'll find that, it's kind of like a lot of the methods tend to be really small, but then you have maybe 20% that tend to be outsized in size and stuff, right? So it's a mathematical thing that happens as a side effect of incremental growth in systems, or incremental value seeking. So the thing I'm always looking at with the system is like, okay, what are the high value areas, right? And my notion of value is a little bit generalized. It's kind of like, it's not just what the business thinks is important, but it's also like, what are you changing frequently right now, for instance? What are the areas that basically are more bug prone? So it's not really value as much as kind of like the highly active areas of the system, the areas where basically you have some criticality, right? And so you look at those and you're kind of like, okay, what can I do to go and actually bring these points into stability? And the thing that's interesting is that the 80-20 rule applies to commits also, right? There's many, many files in your system that you'll probably never change again, right? And there's others where basically you have clusters of changes, and that's going to change over time in the system. But if you're aware of those dynamics, then you basically know where to concentrate your effort. And I think that's the thing that's kind of important with this, is like you can look at a particular area and recognize it's a very stable area of code. It's kind of messed up in the way it's structured and stuff like that, but you're not going to get a return benefit for investing in that beyond a certain point. It's like you want to stabilize it, understand with tests what's possible within that particular area of code, but you don't want to kind of like bolster it up in a way that basically makes it a place which is extremely easy to go and work in, because you're not going to get the value back from this. So I think having a very comprehensive conversation, in the team and within the organization about where these hotspots are and where these value centers are within the system, and understanding what you're going to concentrate on, is very important. And a lot of this is really kind of outlined by Eric Evans, like in domain-driven design. So you have like the notion of bounded context and these different things. And he mentions with like anti-corruption layer and all these different, patterns, that it's really about going and finding these high value areas and sort of like working on that. And I think that's the thing. It's not an easy thing necessarily, but I think the thing we need to recognize is that, value is not uniformly distributed across systems. It simply isn't. And we should behave differently in different areas of the system because of that.
Yeah, I know that hotspot detection is a major part of the code quality tool CodeScene. Do you use tools like that?
Well, I've used it a bit. I'm actually on the advisory board of CodeScene, right? So I know Adam Tornhill from way back when he wrote his first book, and a great guy. And I like that, because I think the interesting thing, I remember seeing years ago that it's kind of like there's a lot of information in our repositories that we just don't really think about. And he just sort of launched in there and started going and digging and developing tooling around that sort of thing. So I think that's extremely valuable. I think it's one of those things where you can either kind of like work on things without much awareness, or you can basically build awareness. And a lot of this tooling goes and gives you the ability to go and find hotspots, but also do things like planning, if a person's going to leave, what it has to impact the code base, and various different things like that are really good for the sustainability of systems. Mm-hmm. But, it's like SonarQube is good too. There's lots of tooling out there that basically supports this kind of an effort, and that's good.
Mm-hmm. How should an organization sort of tackle this problem? How much time should they invest? Like, what policies should they put in place to get some of their legacy code down? Yeah,
that's an interesting thing. So I think it really comes down to that kind of value analysis I was talking about a little bit earlier, right? And just sort of figuring out, and there's things like application portfolio analysis and all these different things that people tend to do, but you need to figure out what's critical. And a term I use quite often is rules of engagement. It's kind of like if you figure out where the very critical areas of the system are, you might say, well, people can't just go and commit against these things. You need pull requests with particular people. They need to go and actually review them. And you do this in order to go and sort of build up stability in these particular areas. And other areas, it might be just, well, anybody can go and sort of commit against this, and that's okay, because it's low, criticality. But getting people to see that value across the organization is really the first step, that kind of thing. The secondary thing is kind of like figuring out whether you're really organized in a way to go and do these things well, right? A lot of times historical reasons lead us to going and having like different fault lines in organizations. We're basically separated in different teams that end up producing strange Conway's law effects that are kind of like there. I am a fan of the team topologies work. I think it's really kind of good. I think if I had any little criticism at all, it's kind of like it arrives at a very normative, it arrives at a very like, this is the way you should organize. And that's good because it does seem to cover a lot, but I always tend to want people to go and think about, what are the forces that lead you into trouble and how can you actually sort of like move them in a way where basically the problem disappears in some sense. So I think those are kind of like macro level things. And beyond that, it's like building a culture of refactoring. And it's like, I think, to the degree that basically the refactorings are talked about in retros, that basically people work on refactorings together, that people can actually sort of speak up when they think something's bad, right? I think is really the important thing. It just really comes down to basically raising awareness within teams. And I think also kind of like connecting with having the developers connect their pain with a solution, right? It's always been troubling to me to find developers that are basically doing very painful things. And they don't think about it as pain, they think about it as normal, right? And then you can show them how they can make their environment a little bit better. And then they're kind of like, oh, wow, I have something I can do here, which is kind of powerful. And I know this is a long answer, but the whole 80-20 thing is really so valuable there, right? Because essentially it's like, if you make a little area of the system better and you're there because, you were called in to fix something, if that's an area where you get lots and lots of change, you're basically going and making things a little bit better. And then the next person's going to get that benefit. The areas where you do this that are high criticality are going to get a lot of change. And then the things that you do to make things better are going to basically give you almost immediate return on these things. Maybe other areas of the system are just never hit in the sense that you never have to go and add testing because somebody's ever changing them. But it's not like you look at a 10,000 file code base and say, oh my God, we're doomed because we'll never get tests for that 10,000 files. There's a certain nugget of the system that basically your set of nuggets of the system that once you start making a headway, then you start feeling the benefits. And that's a very useful thing to get across.
You have this thing in the book, when you have to make a change of a very complex part of the system, people will sit down and try to understand it because it feels suspiciously like work, I think you say in the book, which is...
Yeah.
Which I thought was a very humorous way of saying it. I sort of try to hack into that and give them something else that is actually valuable, like breaking up methods. And it's easy also. They can do it without their brain, right? That's sort of whenever your eyes glass over, have people do something sort of meaningful with that time because they can't tackle problems if they're cognitively exhausted, so to speak. Like have them do something with their hands, right? Instead.
Totally. Just one little plug for something else. There's a small thing I mentioned in the book that I wish I'd really written about more. Every time I talk to people, I sort of offered them as a possibility, and it's scratch refactoring, which is kind of like take the code, throw it into a file, like just a straight, text file as opposed to like your programming language file. So you don't have all the markup about, possible errors and stuff like that, and just start renaming things and moving things around, and don't worry about breaking things because you're never going to check it in. And that basically is like, it's so counter to our intuition as developers because we're always so cautious about how we change things. But when you're not going to check in things, just by going and being kind of hands-on, you start to go and gain much more insight into the thing that you're working in. Even if you can't actually sort of like fix things right away, at least you get a sense of where the danger zones are and stuff like that. So,
yeah, and I love the scratch refactoring thing. Also, I noted it in my notes because it's very similar to what I would just call all of the refactoring that I do, basically. Except I also check it in and I take smaller steps and a little bit of that extra things. But it's very much the thing that if you try to understand it, if you start with this, if you think about it too big, you won't go anywhere with it, right? You'll just be stuck, sort of paralyzed for opportunity.
Sometimes getting past fear is taking the first step. That's the way it goes.
And trying something out and like just, doing it. As you also say, like start writing like a single test or something. If you have something like, you can start improving the quality fairly quickly just a little bit.
Yeah. And that's like, to me, writing a test is asking a question of the code base. And if you're curious about stuff, and you should be because you're working on it, write those tests.
I think we don't have too much more time. Is there something you want to sort of plug here before we end it up?
Not necessarily. I think the thing is, it seems like the AI stuff is going to change things a lot in the short term. And that's, maybe we look back at this and say, we thought it was, but it really didn't. But I think the bet right now is that it's going to change a bunch of different things. But I think the key thing is that when you're working in legacy systems, it's kind of like you get a real opportunity to learn more about how design works in a way. And so there is something exciting about doing that. You get to learn more about design. And I think that a lot of the things that we basically know about design are things that are going to be still very important as we move forward in the industry. It's really kind of hard for me to imagine a situation where for all development, we get to the point where we don't have to think about cohesion and coupling and all these different things. We might have to think about them at a different level. But so much of learning about these things is immersing yourself in it. And legacy code is a place to learn. And that's the way I kind of look at it.
Spot on. I totally agree.
Cool.
Thank you very much, Michael, for sitting down with me. It's been super fun.
Yeah, it has. It's fun. Thanks for interviewing.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.